let's talk about maybe water accumulation in suits, because this has come up in conversation just before with us talking about some of the things that have happened in EVAs. And is there any kind of cutoff point where NASA eventually says, oh, you got too much water in your suit, you have to get back into the space station?
I'm sure if the astronaut doesn't say something first and just make a decision locally, which astronauts are empowered to do, then yes, mission control is going to weigh in and say it's time to terminate the EVA. We had two problems with my suit on my first EVA. One was fan speed wasn't staying constant; it was gradually declining, which could have been evidence of, say, worn out bearings in this fan. And this fan was a fan and pump, was pushing clean air around the suit for me to breathe, and also pumping water around to keep me cool. Two things that have to happen in the suit for the suit to be safe to wear.
Yeah.
For the EVA to continue. Mission Control never told me about the fan problem, but they were very aware of it, I learned later. And they were monitoring it to see how degraded the fan performance was. And obviously
you were like a guinea pig?
In a good way. Obviously, and I'm happy about this, they decided that it wasn't so degraded that the spacewalk couldn't continue. And that was good.
Fair enough.
The other problem we had towards the end of the CVA was that I got a little bit of water. The oxygen, by the way, is blown in over the top of your head and blows down the faceplate. And this does two things. It keeps the faceplate clear of condensation. There's dry oxygen coming in, but it also puts the freshest oxygen right next to your face where you'll breathe it. There was water in that system, and it was being sent, little rivers of it, small rivers were being sent down the inside of the faceplate. I didn't use that EMU, that suit again, at least the upper torso part of it, after that EVA. I think my more experienced crewmate got it for the second EVA. Because if it had led to real trouble, he would have had more training and easier. He would have found it easier to deal with than I on my first or second EVA, I suspect. But that was the same hard upper torso, essentially the same spacesuit that the European Space Agency astronaut wore a couple of years later when they had that very significant water event in the helmet, where there was a large glob of water, and there was, I think, real risk of the astronaut wearing that suit drowning before they could get back to the airlock, repressurize the airlock, and take off the helmet. They made it back. There are probably some strategies for dealing with that kind of problem. The side of the helmet had a vent right here, and that vent had a lock, and you could unlock it and then open the vent. And maybe you could have got the water to go out, some of the water to go out the side vent. Maybe you could try and drink the water. That's a relatively safe thing to do with water. But if you put your face towards it to drink it, and it gets into your nose as well as your mouth,
then you run the risk of drowning again.
You now may suffocate. And so I think that astronaut did really extraordinarily well to stay calm and get back into the airlock in time, because they had a lot of water in the helmet. But that could have been me a few years earlier. Something went wrong with that suit, and I've never heard the full story about what happened.
Yeah, that is kind of that's one of those things that it came up in conversation a few years ago with us, and I didn't even realize it was a thing. Then I read about that one story, and it's all these little things that are. Yeah. I mean, the suit has to be pressurized and has to have forced air, because there's the deep cold of space, and there's also needing, and
you get hot too. I mean, space is a place where heat doesn't get conducted away. It only moves through radiation, and it's very well. Mostly, it's rejected through radiation. Now, the spacesuit is too small to have radiators. It couldn't have giant butterfly wings on the back attached as radiators, because, you wouldn't be able to do an EVA. So instead, it uses an ice pack, and the ice sublimates. It basically sort of boils off and takes the heat with it. So you're rejecting your heat by rejecting water molecules, essentially, that are warmer than when they started. But when you think of all the things that could go wrong with the spacesuit, you could become untethered and float away. The oxygen system could fail. The cooling system could fail. The suit could develop a leak. Any number of things go wrong. You generally don't think of the issue of drowning in the suit. And it just goes to show that, spaceflight, as much as we've practiced it carefully and learned many of the problems, there are new problems out there waiting for us, and we have to have conservative designs and conservative operating principles so that those things, when they happen, don't kill people.
Oh yeah, that's task one. Make it so you can actually get the job done and not die.
Imagine if that spacewalking European astronaut who'd had the water problem had been out on a solo spacewalk. Now, we don't do solo spacewalks, but this is exactly why. If something goes wrong, you need a buddy out there to talk to you, figure it out, see how you're doing, tell mission control, and potentially take you back quickly to the airlock. So when I say conservative operating principles, I mean things like conducting short EVAs, staying close to the airlock, having a buddy. Those are areas of conservatism in EVA planning that help keep people safe.
Reminds me of scuba diving, where it's just you're not even allowed to go into the water for more than a minute without your buddy. So
don't go without a buddy. That's right. No. And don't go without a reliable buddy, somebody you know and trust who's had the same level of training you have.
That's a fair point too. Yeah, for sure. So that one time that you actually had the water problem, would you say that was the most difficult EVA that you performed, or was there another one that was more difficult? Or
well, the water problem was a minor problem for me, more of an annoyance than at the time. It didn't seem like a safety threat. It just was an undesirable performance of the suit. And again, as I said, it was near the end of the first EVA, I think. The things that made EVA difficult were the tasks we had to do. And I think one of the hardest things Bob and I did was roll up the multi-layer insulation, we called it MLI, on top of the cupola, underneath the cupola, around the cupola. The cupola launched with this MLI, this sort of white spacesuit material wrapped around it and held on with Velcro fasteners and so on. And we had to go and roll it up. Now, it's sort of like rolling up a sail or a tent on the ground, except you can't use gravity. So, for example, if you're rolling up a tent, what do? Well, first thing you do is you lay it out very flat on a flat piece of ground, and then you fold it in half, and then you get the air out, and then you fold it in half again, and then maybe at the end, when it's roughly the right size, you roll it up. You put it in a bag. And gravity allows you, for example, to lean hard on that and keep the package small as you're rolling it or folding it. Well, in space, you don't get that assist from gravity. If you're rolling something up, you not only have to do the rolling motion, but you have to constantly compress it. You can't lean on it. You have to put hand underneath on top, perhaps, and compress it as you roll it, so that when you are done, you have a package that is small enough to put a tether around and attach to the back of your suit and head back to the airlock. And it's just really hard. And what are you holding on to while you're doing all this as well? If you're using, you could sort of roll a tent with one hand, right? Yeah, it takes two hands in space, but you need a third hand to hold on to something so you don't float away while you're doing all this. It's
and
holding
also,
things up.
The gloves are super clunky, like these fat fingers. Like I can hardly imagine the effort you'd actually have to expend trying to roll something tight with those big monkey hands.
And you're right. The gloves make it really challenging. In fact, one of the things you learn early as a spacewalker is don't ever hold on to anything like this. It's just too much effort to curl your fingers. You can do it, but you don't want to be doing this for hours. No. So when you hold on to something, you just hold on to it gently like this, and you use the friction between the rubber of your gloves and whatever it is, the handrail you're holding on to stop your hand sliding off. But you don't actually grab handrails, for example, as tightly as you possibly can. And there's no need. You're floating around. You're weightless. The tools are weightless. You don't need to exercise that much control.
Yeah. A lot of the hard parts are taken out of the equation, but I think we take gravity for granted. It's very, very nice to have, and just for little things like rolling up a piece of equipment.